guys, welcome to the video on 4.3. This is on exponential functions. So we're going to evaluate, graph, and solve some exponential equations today. So first of all, and if you guys ever want to pause this so you can try it yourself, please do. That's the whole point of the video lessons. Little refresher on, do you remember the laws of exponents when x and y are greater than 0? So this one, remember when you're multiplying same bases, the base stays the same, but you add the powers. And this one, when you raise a power to a power, you actually multiply, s times t. When you have two different bases and you're raising them both to a power, you need to distribute it in, so it's x to the s, y to the s. 1 to any power is 1. Anything to the 0 power is 1. And anything to a negative power, you drop it like it's hot and the exponent becomes positive. So 1 over x to the s. Okay, so just some little rules there. An exponential function, here is its equation. F of x equals c times a to the x power. Now let's go over what these things are. The c is the y-intercept, and the a can be found by dividing consecutive terms. It kind of tells you how much it's growing or decreasing by. Okay, so it's like the rate of growth or decay. Okay, and then the variable is the x, which is why it's called an exponential. So I'm going to give you guys two tables, and I want you to tell me if it's linear. If it's linear, you guys know the form is y equals mx plus b. Or is it exponential, which we just learned the form is y equals y-intercept times rate to the x power. Or maybe it's neither. You know, maybe it's quadratic or logarithmic or something like that. Okay, so neither. So letter A, let's see, the x's are increasing by 1. And the y's, what's the change in y? To get from one y to the next, it looks like we are subtracting 3. So an addition or subtraction pattern is always linear. Okay, so if you find y equals mx plus b, it's going to be y equals the slope, which is negative 3 over 1, x, plus the y-intercept, which is at 0, 2. So that's the equation. All right, b. Again, pause at any time and try it yourself. This time, the x change is plus 1. And what's the change in each y? This time it looks like we're dividing by 2, which is also known as multiplying by 1/2. All right, so when you guys write the equation, y equals, the y-intercept is 16. The growth or decay rate is you're multiplying by 1/2 each time. So y equals 16 times 1/2 to the x power. Okay, on to graphs. So graphing exponential growth and decay. For these, I like to find the parent function first. So without the transformation, do you guys agree this would be y equals 3 to the x power? And then we'll just deal with the transformation later. Okay, so let's make our table of x and y's. So I'm just going to use negative 1, 0, and 1 today. So 3 to the negative 1 power is 1/3. 3 to the 0 power is 1. And 3 to the 1 power is 3. Okay, so that's our parent function. And I'm going to go ahead and graph that. Negative 1, 1/3, 0, 1, and 1, 3. And I'm just going to make a dotted line because that's not really our answer. That's just our parent function. Okay, now the transformation, you guys know that this means we're shifting everything right 4. So all of our x's, we're going to add 4. So this x is now at 3, this one's now at 4, and this one's now at 5. And now these are our new ordered pairs of our function that we want to graph. So 3 comma 1/3, 4 comma 1, 5 comma 3. Here's going to be our answer, the purple graph. Now, some things to notice: there's always a horizontal asymptote for exponentials, and it's always at 0 unless there's a vertical shift. Okay, so we're going to need to talk about domain, range, and horizontal asymptotes for these. Domain for an exponential is always all reals, because there's no x that you cannot just plug in. But the range, notice the whole graph is above 0. So the range would be all y's such that y is greater than 0. And then there's a horizontal asymptote at y equals 0. Okay, so that's your final answer. Okay, I'm going to do one more graph for you guys in case you need it. Let's get our parent function first, y equals 2 to the x power without any shifts. And let's just see what that looks like. So we'll make our table. I'm going to do -1, 0, 1 again. And let's plug them in. So 2 to the -1 power is 1/2. 2 to the 0 power is 1, and 2 to the 1 power is 2. And if you want to graph that one, we can. -1, 1/2, 0, 1, 1, 2. So again, here is our original without any shifts. But now let's look at the shifts. A negative x means we reflect it over the y-axis, left to right. So our x's are going to become negative. And then a +1 on the outside means we're shifting it up 1, so y plus 1. So this guy's now +1. A -0 is still a 0, and this 1 is now a -1. And then if we add 1 to all of our y's, this is 1.5, 2, and 3. And these greens, that's going to be our new ordered pairs for the function that we want to graph. So 1 comma 1.5, 0 comma 2, and -1 comma 3. Okay, so if we connect the dots here. Now, before I keep going, let's be careful. Because we shifted up 1, the asymptote actually moved up 1 also. So this one's going to level off at 1, not 0. Okay, we need domain, we need range, we need horizontal asymptote. Like we said before, domain of an exponential is always all reals. The range for this one is all y's. Y has to be greater than 0. I'm sorry, actually 1, greater than 1 for this one, because the asymptote cuts it off at 1. And the horizontal asymptote is actually at y equals 1. Okay, doing great. Flip it over. We don't have to do this one, but just a heads up, a lot of times the base will be e. This will come up in a future lesson when we start talking about interest and stuff. So if you want to graph e, you can, let's just actually set up the table. X comma y. So if you did -1, 0, 1, e is just a button on the calculator. So e to the -1, if you just type it in, is 0.37. E to the 0 we know is 1. And e to the first power is 2.72 rounded. So just a heads up, if it ever says e, that's just 2.72. It's a button on the calculator. It's used in calculus a lot. Will come up later. Okay, on to solving exponentials, the last thing. if you guys have an exponential equation and you can get them in terms of the same base, then they're really easy to solve. Okay, so check this out. This side is 3 to the 1 minus 4x. If we could write 1/3 as a power of 3, what would it be? It would be 3 to the negative 1, right? Because that flips it. And then if you guys have the same base, all you have to do is set the exponents equal to each other and solve for x. So 1 minus 4x equals negative 1. We just have to solve. So if we subtract the 1 over, we get negative 4x equals negative 2. And then if we divide both sides by negative 4, then x is going to be 1/2, and you're done. All right, let's try 6. And again, I hope you guys are pausing so you can try these on your own first. So number 6, if we can get 25 and 5 to be written as the same base, it'll be really easy to solve. So do you guys agree 25 is really just 5 squared? And then 5 is already 5. Okay, so we'll just write it as 5 squared. And then, if they're both base 5, we can just set the exponents equal to each other. So this just becomes, we're just going to multiply 2x squared equals x. And then all you have to do is solve. So if we subtract the x over, we get 2x squared minus x equals 0. Factor out an x, you get 2x minus 1. And therefore our solutions are 0 and 1/2. All right, last one. Same idea. Is there any way we can rewrite 9, 27, and 3 all as a common base? And yes, you would say base 3. So 9 would be 3 squared, 2x. 27 would be 3 cubed, x squared. And then this one already, oh, and I can't see it. I think that's a negative 1. Okay, so now that they're all same bases, we can simplify. But first, let's put this side together. This I'm going to rewrite as 4x, and this I'm going to rewrite as 3x squared. Now, remember the rule. When you multiply same bases, the base stays, but you actually add the powers. So it's 4x plus 3x squared. And now, if both sides have the same base, you can set the exponents equal to each other. Okay, so we just need to solve 3x squared plus 4x equals negative 1. So let's get everything to one side. 3x squared plus 4x plus 1 equals 0, and then we can factor and solve. So this becomes 3x, 1x, 1 and 1, they're all plus. That factor's nice. So our answers are negative 1/3. Oh, I'm cut off here. And negative 1. Okay, nice job, guys. This is the homework, but remember, it's not due until Thursday. All right, thanks for watching.